Good morning. You're watching the Weiss channel. So I'm going to record this class. So it'll be easier to watch the recording. So for people who missed this or who need to look at it again, you can watch the recording. All right. Why did somebody get water and leave the cap off of the water bottle? Why does anybody do something like that? Honest to God. I mean, I often have to go hunting for the cat. Like, what? Who does that? This is not your house. Okay? I don't care if your mother picks up after you. I'm not sure your mother. Okay. On today's recording, I'm going to do a 2-for-1 here. Yesterday, I did not record this for the Weiss channel, so today I am. This first one we did yesterday was lines of symmetry. We draw lines of symmetry. If there are no lines of symmetry, you just click submit. For example, if I think there's a line of symmetry going along here, I would put a dot here and say one here, but that's not a line of symmetry. So I'm going to re-click to make it go away. There are no lines of symmetry here, so I'm just going to click submit. Okay. Here, there is only one line of symmetry, which goes here. I'm going to click here, and I'm going to click here. That is the only line of symmetry because it creates a mirror image, right? Okay. By the way, there is not a line of symmetry here. This is not a line of symmetry because it does not create a mirror image. So I'm going to get rid of that. All right. Now here, this is interesting. To the best of your ability, you got to, for example, there's a line of symmetry here. And then there's here. And then here. And then here. Now the situation is this. There's also symmetry here. Okay. There's also here. There's also here. And here. All right. Now, I want to click submit, and you'll notice that there's a lot of lines of symmetry here. If you can see, the dashed lines show the actual perfect answer. Okay. But if you are way off, it's gonna, Delta Math will mark you wrong. Sorry about that. So just do as well as you can to be as accurate as possible when you do this assignment, okay? Over here, all right. I'm gonna go here and here, okay. Now, I'm gonna go also here and here. And we go here, here, there, and there. Those are my lines of symmetry. I need to click 2 dots. Oh, there's one more here and here. Those should be all of my lines of symmetry, okay? I gotta click 2 dots. I click in 2 locations in order to create a line of symmetry, okay? And that is how you do the lines of symmetry. Now, I am going to show you, that was lines of symmetry. Today, I'm also going to show you rotational symmetry. Rotational symmetry means rotating in a circle, okay? So what you're going to do is, first, you're going to say, does the figure have rotational symmetry? So you got to click in this drop-down menu. It has or does not have. Okay. Erwin, esto es tiene, esto es no tiene. Okay. This has rotational symmetry because if it turns, it will make the exact same figure in a turn. Okay. Now the big question is, how many degrees is the smallest possible rotation that results in the figure being mapped onto itself? Here's what you do. How many arrows are here? 1, 2. I'm sorry, can we watch this? Can we put phones face down, please? Phones face down. Sorry, God forbid I should ever not ask you to put your phones down and you actually watch what I'm doing. I am recording, but the problem is that people don't watch the recordings. Please put the phone face down. Okay, YouTube Cortez, phone face down. Okay. Thank you. Rotational symmetry. How many arrows are there here? 1, 2, 3, 4, 5, 6. 6 arrows, right? How many degrees are in a circle? 360. So if I divide 360 by 6, in fact, I'm going to do that on a calculator. Whoops. If I do 360 and I divide by 6, that equals 60, which means 60 degrees is the smallest possible rotation that results in the figure being mapped onto itself. I'm going to click try. Watch what happens. It's going to move 60 degrees. There it goes. Okay. What happens if I only did, say, 50 degrees? Watch this. Oh, didn't work. All right. Reset. All right. What if I did 80 degrees? No. Reset. So once again, I'm going to do 60 degrees. It needs to go 1 turn. Try. Okay, there, I got it. Okay, so I submit. Yes. Okay. 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 Does this have rotational symmetry? Okay, I'm going to say it does. Let's see. How many of these half circles are there? I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12? Oh my. What's 360? 360 divided by 12. 30 degrees. Okay. So I'm going to try 30 degrees. I'm going to claim 30 degrees is the smallest possible rotation. Try it. There it is. Right? If I tried 20 degrees, no, that doesn't work. Okay. It's got to be 30 degrees. Boom. All you got to do is take 360 and divide by however many things there are. I am on Zoom, yes, because I'm recording this for the Weiss channel. Is there rotational symmetry here? Yes. Okay. And how many, or what's the smallest possible degree rotation? I'm going to say there's 1, 2, 3, 4, 5. Since there's 5 sides, I'm going to take 360 and divide by 5. 72 degrees is going to be the smallest possible rotation. I'm going to try it. There it is, 72. One more time. Right? Okay. So you should definitely try it before you submit your answer. Okay. It's delta math, yeah. Now, I'm going to say this one has rotational symmetry, but I'm not going to count each one of these flags. But I'm going to count by twos. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 36, 360 divided by 10 is going to be 36. Here's why. 36 degrees. Watch what happens. Just like that. Okay. If I tried to say, well, there's 20, that would be 18 degrees. Look what happens after 18 degrees. That it's cute, but that's not rotational symmetry there. Okay. It doesn't map onto itself. You got to go 36. Okay. Okay. Does this one have rotational symmetry? That one does not look like a circle. I'm going to say does not have rotational symmetry. And that's just going to be my answer. I'm right. Okay. Does this one have, oh, yes, it does. I want to find one more that does not. Does this one have rotational symmetry? Nope. Okay. Does this one have rotational symmetry? Nope. Oh, sorry, that one does, never mind. Thought it was a T. This one does not have rotational symmetry. Okay. That's how that works. All right. I gave you another 16 of these. Oh my God. So let's see. It's 9:05. What's your, you've been watching the Weiss channel. That.